Hi, today we are going to start looking at average rate of change and instantaneous rate of change. So we're going to start getting into what calculus is all about, which is rates of change. So if average rate of change of a function f with respect to x over an interval a to b is also known as the slope of a secant line. Now there's a few different equations we know for that. So all through school to this point, you have got slope by change in y over change in x. Now this can be our function's y value at b minus our function's y value at a over an x value of b minus an x value of a, or that can also be written as our function of a plus h minus function of a divided by h, where h is a difference between our two x values. So I have a diagram of that essentially here. So we have our function f of x, which is this purple curving function. I have drawn in a straight line that is connecting our point here to our point here. So this blue line would be our secant point that connects these 2 points. This point here would be given by a comma f of x, which, because our x value is a, is f of a. Now f of a represents a particular y value when our x value equals a. Now, if we have an x value of b, this point up here is given by b comma f of b, where f of b is our y value when we substitute our b value in for x. Now, we can alternatively look at the distance between a to b as h, which changes our coordinate for this into our starting point of a plus h, comma, f of a plus h. Now we use both of these in different times and can use them both to solve questions that relate to this. But essentially, our secant line, once again, is a line that passes through 2 separate points on a curve and essentially gives us our average slope between those 2 points. Now, for example, find the average rate of change for f of x equals 1/2 x squared plus 2 with respect to x over the interval from -2 to 4. So essentially, we want to know the slope, or average slope, between when x is -2. So x is -2 here, and 4, which would be here. So we essentially want to know the slope of this secant line. So the easiest way to get this, in this case, would probably be change in y over change in x, which represents our slope, is f of b minus f of a over b minus a. Now with that, f of b would be our point right here, the y value. So that would be 10. Minus f of a, which would be our y value here, which is 1, 2, 3, 4. Over b minus a, so our x value here, so that was 4, minus our a value, which is -2. So that's 10 minus 4 is 6, over 4 minus -2, which is 6. So our slope for this secant line would be 1. So that's essentially how we'd get secant lines and average rate of change. Instantaneous rate of change, on the other hand, we do very similarly, but instead of, for example, having our secant line over a big distance like this, we want to have our secant line over an infinitesimally small h value. So therefore, our instantaneous rate of change of f with respect to x at x equals a is our slope of a tangent line. So our tangent line is our slope of our line at our particular location. Now, technically, the slope of our tangent line is the derivative of our function at that particular location. So that slope or derivative can be written in a few different ways. It can be written as f, then the symbol is prime, so f prime of a. It can also be written as the derivative of y with respect to x, which is our limit as x approaches a of f of x minus f of a as over x minus a. So you can see that essentially we're trying to get this to be infinitesimally small, so our x values are very close together. Or we can write it as the limit as h approaches 0, so the gap between our x values gets very small, of f of a plus h minus f of a over h. Okay, so I've drawn out a curve here where we have this point A, we know f of a, and we, for example, want to know our slope at that location. So tangent line is the line that just touches a curve at one point, or is the line that passes through two infinitely close points on a curve. As point B approaches point A, the slope of the secant line becomes the slope of the tangent line at point A. So I'll draw out some lines to illustrate this. So let's say, for example, this here, this point here, let's call it B, which that would be given by x comma f of x, or a plus h comma f of a plus h. So if we were to draw a secant line that connects those two, we'd get a line something like this. So we can see right now this line does not match this here at all. And essentially, this point here, we would have called x or a plus h. And this was, and like I was mentioning, this does not match us at all. But if we start moving our points closer to here, so our gap between our x and a decreases between, sorry, this point and this point. So for example, if we went from say here to here, we see it still doesn't match, but it's getting closer. I'll do some more in different colors so that we can see it getting closer and closer to matching. So let's say we go from here to here. Try another one slightly closer because that one we can see still didn't match. That one's looking closer. And we can see that as we get closer and closer, or a smaller and smaller interval, our slope more closely matches that original line. So we'll look at an example. Find the equation of a tangent line to f of x equals 1 half x squared plus 2 at 4 comma 10. So we've got our 1 half x squared plus 2, and we want to know this equation of this line that is tangent at this location 4 comma 10. So there's two different methods. Now I'm going to expect that you're able to do either method. So you need to make sure you know how to do both methods. So method one, we'll use one coordinate system, and method two will use other. So if we're looking for our slope at 4, because we're going to need our slope to get our equation of our tangent line, that's going to equal our limit as x approaches 4 of f of x minus f of 4 over x minus 4. Now what we're going to do is, in the next step, we're going to put in our equation for f of x. So we have the limit as x approaches 4 of f of x, which was 1 half x squared plus 2 minus f of 4. We know at 4, our y value is 10, so we've got minus 10 over x minus 4. So this is the limit as x approaches 4 of 1 half x squared minus 8 over x minus 4. Now what I can do next is factor out this 1 half. So that gives us our limit as x approaches 4 of 1 half times x squared minus 16 over x minus 4. Now I recognize this is a difference of squares, so I would factor that. So that gives us our limit as x approaches 4 of 1 half times x minus 4 times x plus 4 over x minus 4. Our x minus 4s can cancel out. So that leaves us with our limit as x approaches 4 of 1 half times x plus 4. At this point, this function exists at 4, so we can just do our direct substitution. So it's going to equal 1 half times 4 plus 4. So that would be 1 half times 8, which is 4, which is our slope, or our f prime of 4. So now that we have that, we wanted the equation of our tangent line. So I would use the point slope form, which was essentially y minus y1 equals m times x minus x1. So that'd give us y minus y1, which we know this point. So this will be our y1, this will be our x1. So y minus 10 equals our slope, which was 4, times x minus x1, which is 4. So that would be our equation of this tangent line. Okay, so as with our first method, We will do it with a second method. Second method, to get our slope at 4, we can use our limit as h approaches 0 of f of 4 plus h minus f of 4 over h. Now this equals, we'll substitute in our function for this, and our 4 plus h is going to take place of our x. So we'd have our limit as h approaches 0 of 1/2 of 4 plus h squared minus f of 4. Or sorry, we've got, we also have the plus 2, so we have to include that. And then we've got minus f of 4, which would be minus 10 over h. So that gives us limit as h approaches 0 of 1/2 times, when we FOIL this out, that gives us 16 plus 8h plus h squared, then close bracket. And then we can combine our positive 2 and negative 10, so minus 8. Over h. We'll multiply for 1/2 in, so equals our limit as h approaches 0 of 8 plus 4h plus 1/2 h squared minus 8 over h. Now, what we'll see at this step is we've got positive 8 and negative 8, so they're just going to cancel out. So this simplifies down to our limit as h approaches 0 of, I'll reorder these, so I've got my largest exponent first. So of 1/2 h squared plus 4h divided by h. Now I can divide each of these by h and simplify further. So I've got my limit as h approaches 0 of 1/2 h squared divided by h is 1/2 h. And then 4h divided by h is 4. At this point, we'll substitute our 0 in. So we've got equals 1/2 times 0 plus 4. So therefore, we have 4 is equal to f prime of 4. So we got the same slope as we did using the other method, and then we would get the exact same equation.